Welcome everyone to another episode of Tevora Talks. I am your host Cash, joined as always by my co-host and partner in cybercrime, Matt Mosley. How you doing, Matt?
Good,
How's it
good.
going?
Super excited for today.
Super excited. Yeah, today is a fun day because I always like the days that we do a little bit different things. Like our hacker history, those are fun days. But today is one of my favorite kind of days, is when we get to interview some of our fellow cybersecurity professionals out there. And
Yeah.
I kind of like the topic that we're going to kind of go down today. And I kind of like to build the suspense, right? I don't want to give away all the beans of who we're about to bring on. But what do you feel about the topic of the day?
I mean, I know him, so he's kind of lame, but I think everyone else will enjoy him. No, I'm just kidding. He's a good buddy of mine from a job a little while ago. It's good to catch up. So I'm excited to hear his input on a few topics, and I think our audience will like it as well. So
Yeah, I think so. And it's right up my alley. So I definitely have some questions for you. Without further ado, let's kind of build it up. My drum roll, please. So today, our very special guest is um, our very special guest has been working for large organizations in cybersecurity for over 25 years. Last 14 years focused on security operations centers, and he's been implementing tools like SIEM, SOAR, and helping other IR teams with plans and operation plans, etc. Been on multiple think tanks. The list is endless. It goes on and on and on. But without further ado, I want to give it up for the CEO of Cyber Threat Cognitive Intelligence, Andrew Grealy. Andrew, welcome to the show for our three
Thanks,
listeners
thanks.
out there.
It's good to be
Yeah.
here. I'm excited to be on the show today. Not as excited as Tom Cruise going to Oprah's talks, but still excited to say.
I mean, when we get back in the office, we'll get a couch for you. You can jump on that. We'll put it on video. No worries.
That'd be awesome, buddy. That'd be awesome. My kids would like a couple of back somersaults or something off the couch. They love that.
Tom Cruise is constantly hitting us up. We have to cancel all the time with that guy.
It's like Matt Damon. Oh, Matt's supposed to be here today.
Yeah,
exactly.
We don't have time.
Yeah. But yeah, thanks for giving us your time. If you want to give a little bit more info, shout out yourself a little shameless plug, do it all, get it going. And then I want to get into like the highlight topic of the day, which obviously revolves around your company. But pass it to you. Let's give a little more insight of who is Andrew Grealy.
Yeah, sure. Hi, I'm Andrew Grealy. I'm the CEO of Cyber Threat Cognitive Intelligence. It's a bit of a mouthful, and my Australian accent, I always have to write it down CTCI because people write CICT and AI because it's now, and it's a .ai company, so it all gets a little bit confusing for people with my accent. So Mike, the good thing is Mike, my co-founder, he's American and he talks straight, so people understand him better than I do. So he's my guy that says, "Can you speak back American?" To make it easy for everyone, right? So if you don't understand half I say tonight, that's okay. That's normal, right? So if you understand 10% today, that's awesome, right? You're doing great.
The 10% is good.
Mike
we'll get some
and
subtitles.
Yeah, totally. Mike and I, and sometimes I'll throw in some Australian jargon, and we'll have to put out what that means. Busier than we'll get into a few of those jargon. But one thing there is Mike and I knew each other from Nike. I was in cyber threat analytics. Matt was there at the time back in the old days when Moses played football.
Yeah.
I was there and I was in cyber threat analytics. So my job's to find the bad stuff in the data. You got 40 odd terabytes of data. You got to find the malicious, detect malicious events, right? And Mike was the SME in cyber threat intel, and he's giving me the intel. And when I compared the intel I was getting from all these tips, threat intel providers, and I was getting false positives, up the razoo, 900 to 1, and all the stuff Mike gave me was actually something I had to action. So we end up having lunches on Friday at Red Robin, and I said, Mike, your stuff is actually the good stuff. We actually use it. We get value out of it. And then talking backwards and forwards over a long time, we decided to do the normal thing in a pandemic and leave a really good job in a Fortune 100 and do a startup. Always a smart decision early up, right? So, and what Nike has one really cool statement, right? It says, where do you edit to amplify, right? Where can you make a difference? We worked out that, well, we can make a difference here, but we could actually help 1,000 firms. And at that time, lots of hospitals were getting compromised. And that was bad. So we said, you know, let's help those hospitals out of what they need to patch right now, what things they need to look for, and what a threat actor's doing. So we started, and I wanted to always work for a cool company. So we created a product called Cool, which is the CVE early warning list. Is what CVE threat actors are using now or imminently about to use. And we have in that, like, threat intelligence has got some bad names over the years with Norse and that sort of stuff over the years. So we wanted to be a legit company. So we created the product Legit, which is lookup explanation for genuine IP threats. So it's all IP IOCs, and you can actually log onto the website today, register, and use that today. So it's 400 feeds of IP addresses and IOCs that you can check for. And the great thing is it has when it was added, when it was minus, so you can see if it's been repetitive in different types of CNC channels, attacks, and things like that.
Oh, very
and
cool.
we have the product Fast, which is flash alerts. We had to get a product name, so flash alerts for security threats, which is anytime we find something that's like nuclear or really important right now, we send it out. And in that, we try to give people things to look for in the logs, like threat hunting if you've already been compromised, things to detect or put in your WAF rules. And later on, we're going to add them as Sigma rules so people can put them in all their SIMs and that sort of stuff. And we're building another product. We just, I've been head down, bum up. You know, I've been a data scientist for years. And I don't know if you guys know, there's a thing called MITRE ATT&CK framework, which a lot of people know, and has techniques what threat actors are doing. And one really hard problem is going through documents and pulling out what the information out of those documents and matching them to those 256 different groups of TTPs. So MITRE released a product called TRAM, which is to take that and to take those TTPs out. But it uses old, not deep learning and all the new models of the world. And it's a great job what they've done in the first place, but it only extracts an accuracy of 65%. So I just built a tool that's about 99.86% of pulling those out. I've done it from 128 different techniques. I still have to roll it out to the 256. And we're going to have that as a tool as well. So cyber threat intel people and SOC teams and that can use this tool, and they'll be able to extract all the TTPs with the techniques. And then the great thing is with vendors today, they're matching whether the product detects or prevents against those TTPs. So if we say, here's what threat actors are doing, here's the TTPs they're using, and then you match that to your tool and see whether they protect or detect that problem. And that gives you a better say, because the hard thing today is when we say to people, you know, one of the hardest problems is what are threat actors doing? And we've got that covered, and our threat intel team do an amazing job there. The next part there is, how do I use that, right? And one part there is, hey, I could patch, but when I give you that list and you match with your list, you see about a 95% reduction, but you still have to, for each one of those, apply that to your environment, right? Is this in the, do I have to do the work to say for each of these CVEs, is it protecting the environment? Is it behind firewalls? Is it public facing? Do I have other controls? Do I have EDR tools? Do I have all these other things? So if I can
which product is this?
What's that?
Which product of this is of the 4 that you guys have? Which one is this?
Oh, we haven't given a name for it yet.
Oh, you're working on it. Oh,
this is the new. It's maybe we can come back and show you.
Yeah, definitely. Yeah, we do like a raw version of that right now. It's very manual that we can talk about it, but like it uses the MITRE ATT&CK framework, and then we basically wrote a bunch of scripts that would go through and test those different areas and then do like a heat map. But yours sounds way better. Way less labor intensive.
Yeah, well, the thing there is, if you go to the testing now for MITRE, you'll see like CrowdStrike and all other vendors saying which techniques they protect against.
Yeah,
right.
And then the actors can just the threat actors can say, oh, well, you don't protect against this, so that's what I'll use.
Yeah. But the first thing there is from that knowing what threat actors are doing and then extracting those TTPs. And then we can help people auto match with that MITRE ATT&CK framework with the products to reduce the work in the environment, right? To make that, now this is really something you need to do, and then work out which to deploy the countermeasure. But yeah, the problem with the MITRE ATT&CK framework is they're in multiple classifications too, right? So a file dropper can be in a number of different evasion techniques and process techniques and that sort of stuff as well. So I have mine can go in multiple and that sort of stuff as well.
Cool.
So if you say, hey, use WMI to access this and baited using an email phishing for this and spear, then I'll grab those 3 techniques out and put those techniques. And then I'll do what we call evidence-based hopping. So I'll go back and do an evidence to say, given this information, where is that information found in this documentation? And then we match that to our documentation of what we have for our reference. So yeah, it's called multi-hop evidence reasoning. If you look it up in machine learning AI. And of course, we use the latest in NLP models, your GPT, your BERT, all those big models that are changing the world, you know?
Yeah. So that's actually why I really wanted to talk to you, because I hear the term AI used a lot, and I'm sure you do too.
Yeah.
And I really, to me, it's like kind of a bunch of what if statements, right? But I think there's a lot more to it, and that's just me because I don't know that much about it. That's what I think of, and I think Cash and I have talked about this as well. So I guess, what can you tell us a little bit about AI? What your thoughts are on the security space, how it's going to play in the long term for us in our industry? Are we going to be replaced? Is what I'm really getting at.
Yeah. So I think let me do a 101 for machine learning and AI, right? If your vendor says I use AI, there's no vendor I know that uses AI, right? So if I say AI is true reasoning, right? It's like a person reasoning about a problem, right? Today we use machine learning because I say, if you're using Python, you're doing machine learning, no AI, right? And nearly everyone's writing stuff. All the tools today, TensorFlow, PyTorch, all those are written in Python, right? You build the model, you run that, and you do that sort of stuff. And what we've found with the machine learning, with the number of these, what we call deep learning, where just say Facebook or Google goes and indexes, 1.2 million documents, and then works out in their machine learning to work out how do people normally talk and ask questions about it, called Squad. So you can do question and answer. So with the tool, because they've learned 1.2 billion documents, they've learned how people write sentences, and then they've worked out how to retrieve that information from that document.
Okay.
Right.
Yep.
It looks like it's amazing, right? You type it in saying, who was the first president of America? George Washington. It's like, wow, that's amazing. Who was the second? All right. But if you asked it reasoning, who do you think should be who do you think should have been the first president? The information is still there in that document, but it doesn't know how to understand that. It doesn't understand cause and reasoning. But it's learned enough to do extraction that it's equal to. There's a clause that for a human being is like 97, and we're at like 98 now. So the computer can reason a paragraph just as good as a human, if not better. And it's then people think that's AI because it's like it's doing better than a human. But realistically, it's just what we call curve fitted. It's fitted for all that information to get that answer. But if you ask the reasons why it said that, it's like, well, I just went through these leaves of a tree until I got to this point, and that's what I did. And I gave that answer.
Yeah.
And the same thing with like convolution neural networks, they're picture networks, right? So I don't know if you've seen the ones for X-rays, right? If I was a radiographer today, I would get the computer models they have today, which is called UNet, and I would open a clinic with like 45 different offices and just do it all remote with video camera, and the computer can actually do a better job than me finding on the X-ray where the breaks are. Because in the future, when they say a computer can just do it instead of the radiographer won't exist. And I think with computer, with machine learning and AI, I think probably 15%. Like I did the work at last company. I was on the think tank for AI there and machine learning, and it's probably about 15% of the jobs are only needed after that. And the funniest thing about it, jobs, you can say, well, what is the funniest thing? How people spend a lot of time being a specialist, right? The more specialist you are, the greater chance a computer will replace you. If you're a jack of all trades, the computer can't do 42 different models and jump in between it.
But for example, Cash and I are good, so that's good.
Like a radiographer, right? They look at X-rays all day. Well, computer can learn those, those breaks and that stuff. Patterns, and it doesn't get tired at lunchtime. It can work 24/7. right?
Yeah.
And do a better than a human being can detect that, right? If
Yeah.
you're a lawyer, they're doing lots of legal analysis tools that will give you what a magistrate or a jury would say, right? So the more specific your job you have, I think the greater the chance the computers will end up replaced.
So
Okay.
I got a question for you here. I did a little AI stuff, and I get your input. The more you give it, it looks through it, it learns from it, it creates a new leaf node, etc. And you kind of keep rinsing, repeat, and that's the whole machine learning part of it, right? After
Yep.
you kind of do the initial base programming of here, this is how it gets kickstarted, and we're just going to keep giving you new data, right? So how does that really tie into what you're doing, right? Because we have Google's image recognition. They kind of take the reins. Now, if you have the Google app, you can upload a picture, it'll scan it, it'll try and find relative stuff, but that's like the basic. That's not really um, very intellectual necessarily, because it's just like you said, it's just going down and finding a matching leaf node, right? Based on probability. But right now, how is yours intellectually determining, hey, this is a new threat? Is it based off of patterns? What is your input sources? Because, we did a recent podcast with another gentleman about same thing, threat intel. And based on threat intel, it's like, hey, we're combing the dark web. We're in these blog channels very discreetly, and that's human interaction, right? And we're trying to do our best not to go detected. At what point do you take your human notes? Are you guys doing that? Are you guys pumping that daily, hourly, every minute into your, machine learning algorithms? How is your AI structured around the new data set of all that world?
Without giving
Yeah,
away secrets.
that's a great question. Mike Freeman's coming on the show sometime, and he can go to it in more detail, but I can give you a high level point of view from our machine learning point of view, right?
Yeah.
There's a number of ways to tackle the problem, right? So one way to tackle the problem, like we're doing CVE threat intel, right, is to regex the world for CVEs, right? So if you look at some other threat intel vendors that do a big job, great job of collection, and they'll search the web for that CVE. Ours is NLP driven. So we're trying to understand conversations about information. So
are those conversations on the dark web, or are they not on the dark web?
From the dark web, our team are in lots of OODA loops in threat actors in APT groups, right? So there's a lot of parts that we're in that we're seeing that information, right? So the first thing there is for us from a natural language processing is to understand interesting communications about stuff. So we're not interested if a person is talking about, has anyone got this exploit, right? And you'll see lots of those if you just did collections. We're interested in what are people saying about the EIP register for Internet Explorer. So we're doing NLP driven to find those interesting conversations. Then from those interesting conversations, for each of the different sources, we give them a ranking, right? Credibility ranking. Like we don't use National Enquirer, but we'd give that a 0.0001, right? And would give something like, Kaspersky's APT report, we'd give it a 98% because they're not timely, but the stuff they have in there is valid. Or Krebs would say, hey, he's pretty good for a number of parts. And then we put from each of those sources what topics they're experts in. And then we do machine learning for threat determination. What are they talking about? So we ask questions in machine learning. What are they talking about? And then, is that interesting? Is that something we already know? And what is the threat determination of this? And then we go search other sources that can make that, whether that's credible or not, right? So we say, are other people talking about that same information? And then we go there. And for example, Mike's NLP crawler goes and gets 350,000 different sources last month. And out of those, we ranked those, only 6,000 of those were credible that gets added into the process. So
is the initial trigger, like a CV, a new CV comes out, and then your machine will just go and intellectually just find every impossible thing there is about that? Or is your engine also able to discover new CVs and create those?
Yeah. So there's three parts of our process. One is we have honeypots, right? So we have geographic honeypots. We have company verticals. We have banks that are in there that look like that. We built a Tesla one, and we found a 0 day with Tesla, which was great because I said, Mike, we got to build a Tesla.
That's cool.
So Mike builds those honeypots. We want to have honey clients like your browsers, your phones, and those sort of things, and then different levels of interaction sites. And we have some really really important organizations, just say like oil and gas, that you have to burn a 0 day to compromise it because it's so secure, right? So we have those honeypots feed the part. We have our Intel collection that's doing NLP and ranking the data. And then on Patch Tuesday and Linux diffs, Mike will do a bin diff between what came out at Patch Tuesday, and then he'll see if we're seeing these 200 odd exploits matching that we're seeing in the 0 days, that we're seeing in the wild, and what CVEs are. If they match that, we say, on the day of the CVE, we say, this is real. We're seeing this in the wild. This is something we need to do right now, right?
Yeah,
and then we do.
That's pretty cool. If you're giving free 0 day warnings, you know, as part of your intellectual service, these bounty hunters are going to be out of the gig soon.
Definitely a lot more moving parts and layers than I was aware of, obviously. So that's good. That's
and then we go through, like, for example, GitHub. We will go through the history, well, all the new POCs for those CVEs, and we'll run those SMT solvers to see if it actually follows the path that gets compromised. And then we see a lot of them are fake and wreck your machine and, you know, backdoors and that sort of stuff, right? So if they don't follow the path that we expect, and then Mike runs that tool and it does exploit generation. We do auto exploit generation for variations of that and how well it lands. And then we put that into the honeypots for stuff we don't have.
So do you have like a side business just doing bug bounties too?
No, we don't want to get in that business. Like, we've always been asked, like, you know, from a number of organizations, let me tell you, say, can we get, can we get those exploits in the 0 days? And we say, no. And we even added in our honeypots and the Haskell lights, we even added replay so we can actually get the whole compromise and parts, that sort of stuff. But the thing there is, we know if one person gets it, he sends it to friends, and then we've wrecked the whole world, right? We're about making a difference and making it more secure. You know, I've been on the good side for many years, and I like to stay on that side.
Yeah.
And the other thing there, we do threat clock, right? So we have this thing called our CTCI threat clock. And basically, if Bitcoin goes up, like it's going to 60,000, miners get compromised. We're seeing 2012, 2014 JBoss exploits and all that stuff. You see them come back and they work out new paths for mining. And then when Bitcoin goes down, we see ransomware, more from your Adobe, you know, and that's the stuff. So that threat cycle, that threat clock is really important. And then we look at other trends we're seeing as well, right? You know, Kubernetes wasn't anything 8 years ago. Now Kubernetes is everywhere, right?
And it's the hot topic for sure.
Yeah, a lot more exploits in container and Kubernetes now, right? So, and a lot of vulnerability scanners don't see that. So we say, oh, we got to match that and look for those things as well. And also we have special access to certain data in different groups that other organizations don't. And we have some private data exchanges and those things that really help us as well. So there's you know, in some organizations just do honeypots, and some organizations do Intel collection, and we do Intel collection, honeypots, curated and then validated. We always validate our stuff, right? And that's where we, you know, because our list is the list, right? If we say it's on there, we've got a high bar to get it on there, and once it's on there, we're like, we class that as like a CVSS critical, because that's what threat actors are using right now. And in our list, we see about 80% of all the entries are non-critical of what threat actors are using, because they don't say, oh, I might just send it as a critical.
Right? Yeah, you know, when it comes to the severity ratings, you know, sometimes when these CVEs come out, they're initially very blanketed, right? They're like high, you know, everything's a high. So it's like, what is your validation of the criticality, right? Because some of these CVEs, they're brand new, 2021 or whatever, no proof of concept. It's like, hey, here's a vulnerability, but man, you have to like,
they require those planets to align.
You have to have this, this needed to be used. You had to call this function, no validation, input scrubbing. It's like, dude, come on, you know, this is like not even a low. So how are you guys going? Are you, is your platform, is your engine able to intellectually
I think if you take it a slightly different way, right? There's many ways to slice and dice this, right? If you take the vulnerability management products today, right, they have to cover every vulnerability, right? Because they're trying to do checks for every vulnerability out there, right? And they're trying to do collections for that and information, do prioritization and some ranking associated with them. We're focusing very differently from the threat actors. What are they focusing on and what are they doing? right? So instead of it being 200,000 CVEs, it becomes a lot smaller number that they're focusing on doing. And then we focus on that as the path, right? So, so a lot of CVEs come out with 1 or 2 lines, but we'll be seeing that in the patch diff of what actually is going on, and then matching that for other stuff we're seeing. Or seeing that this APT group is about to launch an attack using this vulnerability, and then we'll alert customers of that. Say, hey, we're seeing this, they're about to do this. You need to, and that's the fast alerts. So yeah, and I think it's slightly different mindset, is that we're trying to find stuff that is being actively exploited or imminently about to be exploited. And through our collection, through our NLP, through our processing, and threat determination to do that. Whereas others are doing prediction, right? They're saying, and if you look at the predicted models out there, having background in machine learning, the prediction models are terrible because you have to give a weight associated to something like Apple, and they give a weight to Apple vendor to say, oh, it's not really important. But it's because Apple never report back to NVD the real score. So when people do machine learning on Apple in the NVD database, it comes with 0. So they say it's not important. But I can guarantee you browsers on Apple products are very important.
Yeah,
right.
For sure.
So
I mean, I've gotten persistence on Apple products through Safari.
Exactly. So we focus on those
WebKit.
parts to say, you know, have the honey clients for those, right? To go to the bad sites to get compromised and that sort of stuff.
So how much, you know, like you said, let's take it back, right? Artificial intelligence.
Yeah.
I think there's a lot of great uses, right? Especially in medical. Medical is always the best case, right? It's like, hey, you want to go to a doctor. Doctor's like, hey, you got cancer. And then nowadays you don't go to only that doctor and that's it. This man in my world, doctor said I got cancer. No, you go to the second doctor and then maybe a third one, and who knows, right? But at the end of the day, third opinion, that's still a lot of opinions, and it's like that takes time. So I mean, medical, great uses. Hey, in you know, a millisecond, I can have this engine scan a million x-rays simultaneously, input from all these different doctors in this ginormous medical database, and definitely conclude, hey, with high probability this is in fact or it's not cancer, right?
Yeah,
so huge there.
100%.
But then again, to your point, you said that doesn't mean the radiologist will ever be replaced, right?
Oh, I think the radiologist will be replaced. I'm saying if I was a radiologist, sorry, could I say something?
When though, right? At what point do we fully trust the AI?
Here's 2 things, right? The first thing there, I said, if I was a radiologist, I would make it rain as much as possible, because I believe there's a future where a radiographer is not needed, right? You got me?
Of course.
Right? It just has to get to a point where the governance of that says that yes or no, right? So if you're an individual radiographer and you still have, just say in the next 10 years, you still need to have someone verify it. Well, radiographer can sample 1 million of them and say, yep, they're still looking good, done, right? You don't need a radiographer every person for every hospital, right? You can do that tally, right? To one place, and the person can have 20 monitors and like, yes, agree with the computer, done. You can have one instead of every hospital having 10 radiographers or so.
Yeah,
or whatever
I think that definitely would probably be the more realistic picture, because I mean, even with like Tesla, right, we see the auto driving, it's doing tons of calculations, making the right decisions, et cetera, right? But then we still hear stories about, oh, the Tesla thought the sun was a yellow light or a red light or whatever it was, I can't remember now, but because it picked it up on the horizon, it misinterpreted that that's actually a star and not a stoplight. And I think you definitely need to have some human, it's just like planes nowadays can run on autopilot for sure. But I definitely, as a human, don't want to be solely like I still want a pilot in the seat that can take over if need be.
Well, I don't know if you know, but most planes in Australia run by fly-by-wire. The pilot has it's like 7 out of 10 landings are all computer controlled.
Oh, I believe it, but there's still a pilot there, right?
Yeah, but still 20 years, there's not enough time for them. But here's a difference. Remember I said in machine learning, we're in machine learning today, not AI. So Matt, it's not cause and relationship. It can't understand that. And driving cars is really hard, right? You know, the example from a mate of mine that works at Waymo, he says, if a person driving sees a ball come out, like a little ball, a ball roll onto the road, they slow down because they know there's probably a kid chasing it, a little kid, right? A computer doesn't know that today. It can't do that cause relationship, right? So that's why the driving today is like curve fitting today. It's just saying, I've learned these sort of things here, and I've done some machine learning, reinforcement learning to make it better, but I still don't understand driving, right? But radiographer, if I have a picture, an X-ray, it's a well-defined domain. It's one picture, and if I took a good picture and UUNet says that's what it is, and it looks up and classifies it, that's where those jobs and roles become very specialized, become really easy for a computer. The more specialized the role is, easier. Driving a car is not specialized, right? That's the hard thing about it. It's so many.
One of the downfalls of our society.
Yeah, you have to make so many decisions, right? Like, you know, you drive down the road and suddenly, work is ahead. You've got to move on to this side. You got to wait here. You got to do that, right? It's a hard thing. But highway driving, less things, unexpected things happen, and the cause effects become a lot easier. And that's where I think AI will, the current curve fitting stuff they're doing, like, you know, images, pictures, audio, like translations of languages, like, you know, they're getting amazing, you know, creating new paragraphs of text, of stories, GANs generating new designs, right? All that stuff is getting amazing. You know, you saw, you know, in like last 6 or 7 years, from a GAN, a generative adversarial network generating a picture, was a garbage. Now you can't tell the difference between that GAN and a real person, right? So
right, I have seen that. One of the AI systems that I'm familiar with, or at least it's been pretty popularized, was IBM Watson. Are you familiar with Watson? So I was on a gig a couple of years ago. In fact, one of our guests, Andrew Gorecki, shout out to that guy. We were doing a incident response for a pretty big breach, and he just, because he works for IBM for the X-Force team, he's like, "Oh yeah, we'll just throw this at Watson and we'll see what Watson comes back with." And I was like, "Look at you, fancy pants." I wish I had a Watson that I could just throw shit at. But what are your thoughts on a Watson? I mean, have you seen any security applications output from Watson, or is there any? Do you have any input on kind of those general AI programs, I guess?
Yeah. So, I think there's a number of ways to tackle that problem. The one that I've spent quite a bit of time in, probably the last 6 years on, is AI virtual SOC analyst. So how do we either assist a virtual a SOC, or how do we replace a SOC analyst, right? Those two different mechanisms. And I think there's a number of problems and areas of types of tickets coming in that you can do that really well. And there's other areas that human beings by default are awesome pattern matchers. We are one of the best pattern matchers in the world. Like, if you ask my wife, if I have one of our paintings at 1 degree off, she can tell it from the other side of the hallway what happened to the painting, right? Because you can straight away see it's not exactly level perfect, right? So
yeah, wives have an uncanny ability to find fault, right?
Well, she finds fault with me every day, buddy. I think she still loves me.
It's like their mutant ability.
Yeah, totally. So human beings are great pattern matching. I've written a paper, and I'm probably going to circulate it after a conference, is all the things wrong with SOAR and how would we make it better for everyone, right? And how that talks about the problem is we try to solve the problem in the wrong way. For example right, you know, IOCs, you got me? IOCs today in SOAR and other products, it's either bad or good. Well, I can tell you, I've still got a Yahoo account, and I probably should turn it off one day. But I get a lot of spam from there, but I still get some good stuff. So I want my IOC is highly likely spam, right? So that IOC doesn't always say it's bad, therefore stop it right now, right? You have to have some sort of normal curve about what that information is. And the other thing there is, I don't know if you've ever watched Sesame Street, right? So Sesame Street is, you know, they have this one of those pictures is not the same, come and join the game. And you got to find out for all those pictures which one's different, right? Now, given data, we should be able to grab what's different and teach that as a computer's evidence. But the problem with SOAR today is people get the same inputs coming out and give it a different answer, right? And you see SOAR tools today, they don't go back and say, hang on, this is the same inputs and you're giving a different answer. Why? Right? And what it could be you're wrong, the other analyst was right. It could be there's new information, or it could be there's another question you asked in your brain what it is. So my view is that we cognitively change the way SOA is done, and we look at it from a point of view to saying, hey, what's it between a bad analyst and a good analyst is the questions they ask, and they keep pulling the thread. So what about in our tool, we ask the questions, hey, what evidence was this and why was that evidence? Machine learning can learn. Remember we talked about understanding text? It can do that well. So, and the other part there is in SOA, right, for example, is it's written by, you know, I can put my hand
It's only
on
as good
heart,
as
I'm to
the
blame.
person that makes the workflows, right?
That's right. They write.
Yeah.
I was one guy write workflows, but the SOC person thinks about the problem a different way.
Right.
And
Exactly.
in Ray Kurzweil's hierarchical of mind, it says you can't, if you have a favorite song, you can't start that song anywhere. You actually start it at the start or the chorus or the part that you like, because your brain's made for, oh, when you know that, it remembers this. So I'm telling, when I write those SOA playbooks, I'm telling a SOC that you've spent all your time learning to say a phishing playbook in your head, and I'm starting you in a different path. I'm asking you different questions. And that causes cognitive upheaval and them not understanding that problem.
Right. It's like that. I think it was Einstein, right? We can't solve problems by using the same kind of thinking that we used to create those problems.
Yeah, that's exactly right. That's exactly right.
Yeah.
And the other part that I get upset with SOA in this cognitive paper is about is that if you look at people today, you know, they're playing games where they've got 40 million things on the screen and they're getting all that information. And how does our SOA playbooks today go? Did it come from the same sender?
Right.
Is the DMARC the same? You know, it's all these questions. I'm like, no, give all the information at once and do it like a TIE fighter, you know, Skyrim, whatever. And then people can actually, we think non-linearly, and we're trained to do linear in the questions we wouldn't ask in the order we're asked. So yeah, so that's how I see AI in the virtual SOC. And after a while, if you give it those inputs to outputs that they can chain and give the evidence of that information, and you match that, then I think you've got a good path for doing AI in that area.
Yeah. So I started off this conversation thinking, cool, I'm not going to be replaced by a robot. But now that we've talked more, I think I'm going to be replaced by a robot. Yeah. So you didn't make me feel any better, but thanks, Andrew.
Well, I think the great thing is, Matt, you're a jack of all trades as well, buddy. So, you know,
Yeah.
too many models. So that's what I'm saying. You know,
Yeah.
if you say I do this, and this, they're like, oh yeah, man.
I'm gonna stick to my crypto trading, although AI will probably take that over too.
Oh yeah.
So any
AI
final
there.
thoughts?
Yeah, so I think that one thing that another question people ask me a lot in machine learning and AI and cyber is, why is it really hard, right? Compared to some other areas, you know, like convolutional neural networks, as you said in
I was going to ask that, but I didn't want to sound like an idiot, but it does sound super hard.
Yeah. And there's probably three parts of that problem that make it hard. The first is getting labeled data, right? It's hard to get lots of labeled data of incidents, right? And real attacks. You know, the ones that people get and that's the stuff are not so much real attacks. Like, you know, people knocking on a door and a firewall is not a real attack, you know, right? The second there is what we call balanced classes. When you machine learn, you have to get the same number beside each other. And a lot of people, when they learn it, they go, oh, here's the bad stuff, here's the good stuff. And the good stuff's 98% of the traffic's good. So the machine learning model goes, well, if you always say it's good, we're 98% accurate, right?
Yeah.
Right. So we have to use these techniques called SMOTE, and there's other different ways to balance classes. So the first part's getting labeled data, which is really hard. The second part is balancing those classes, right? And the third part is adding other features into that columns to make it so you can discern it. And I say something that's really important for people learning machine learning and cybersecurity. And this is 101, and people forget it. It's called what we call exploratory data analysis. And what that means is, there's a thing called in the graph called picture in the visualization called normal, and there's something called malicious. If you can't see it as a human being, the difference in the picture, there's no chance a computer can do it. And people think the computer will work it out and it'll do amazing and no one else can do it. I'm saying no. it can give you different interdependencies that you never knew between these different columns and these different variables. But that's when I say, if I say, can you show it in the screen, that visualization? And if they can, then a computer can learn that like there's no tomorrow. But a lot of people doing machine learning are saying, oh, you'll work it out. And I'm like, yeah, but like for that UNet one example of the teeth or the feeling of the cancer, you can see it in the picture. The computer is just doing what you would do as a human to pattern match. Mm-hmm. So that's really important. If you can't display it in some sort of visualization, and you can do some advanced visualization, then the computer's never going to find it as well. And people just sometimes just chuck machine learning at some cyber problems that they haven't even done 101, explore it and see if you can decide. Right. And that's really important.
That's cool. That's awesome. And good way to approach it. I mean, I know you said that's 101, but I mean, I didn't think about it like that, but I'm not a data scientist. So very cool. Well, thanks for coming on. I appreciate it. Cash, you're good? No,
I'm good. I'm good.
We're all questioning our existence at this point. So. But awesome. No, well, hopefully our jobs don't get taken away too soon. So
yeah, no, I know what I'm going to ask Michael when he comes on. I'll have some follow-up machine learning AI questions for him for sure. But a great insight, Andrew. That definitely on the product, and yeah, excited to see where it goes. You know what? I was just thinking, like in the middle of it, while you were saying about the SOAR and all that. I can't wait till there's like an AI box at some point where you can just plug in your network and it just automatically configures everything for you. It goes and says, oh, this is your entire network. Off ports, on ports, shut this off. You got these CVEs. Let's bring Andrew's tech in here. Flag. And then it fixes itself. And then you just think you're clean.
Totally, buddy.
One last thought, but remember, like Andrew knows, because your cashier a little too young, but remember back in the day when you'd want to play a computer game and you have to do all these configurations just to play with your friends.
Oh, no, IPX, totally.
Yeah, nobody will understand those struggles. None of these younger generations.
No, I don't know that.
Like making sure it's on the right, IO port and all that crap, and IO address and everything. Just
Oh, the DMA cards, your sound cards, the licorice, we call it the thick licorice that you do for LAN parties, and totally. We've had for trumpet windsock on there.
Windsock. Oh God, good times.
All those. Yeah, today.
Bcash, you'll never know. We had to go to school uphill both ways in the snow. You kids have it so well. All right. Well, thanks a lot, Andrew. It's always great to catch up with you. We'll have to grab some beers sometime.
For sure. Love your work.
No, take care. Thanks for coming on. Everybody else listening out there, we'll put a link how you can find Andrew, how you can get a hold of all of his cool tech at Cyber Threat Cognitive Intelligence. Don't forget, subscribe. Any questions, hit us up, hit Andrew up. And I guess that's it for the day. Till next time.